So input. Input is the primitive value of the independent variable. Output. Output is a primitive value of the dependent variable. When do we use a linear model? Whenever a linear approximation matches the given circumstances. And we also have intercepts of a line that include the x and y axis. So just a quick brief overview. So let's see. X value is what we call or define as our input. So x is the input typically. We also call it the independent value. Notice the prefix input, independent. Okay, as a reference, let's also call them parents. So what comes first, parents or kids? Ideally parents, right? Okay, so just a visual reference, not necessarily a question, but just a visual reference. And also we have the y value, which is typically the output. And we define it as the dependent variable. So therefore, in this case, as a reference, to make it easier to visualize, it's the kids. Come second, right? So x, the input, independent, or the parent, come first. And then y, the output, dependent, and kids come second. So you need an input of x to get an output of y, in other words. So let's do a little box there, just for reference. In this case, it's a red box. And what are we doing with this box? Well, let's say we're multiplying inside the box. 3 times x. The idea, let me step it out of reference for a minute. So let's say you work with a carpenter. What do you give a carpenter to work with? Wood, you'd say? So yeah, you provide him wood. What would the carpenter do with the wood? Well, they can make chairs, tables, agreed, or even large materials like a structure, a building, right? Okay, so they can do just about many other components for you, or build something bigger or smaller depending on the case, right? So input, the material, output, the product. But in this case, we're talking about mathematics. So input, a number, output, another number, right? So input, what can we put in? X values. Output, what could we get? It'll be an X value in representation of a number, right? So for instance, let's build a quick table here. To remember, X value always comes first, that's your input, and your output, the Y value. Independent, dependent. Agreed? Okay, so now let's try it out. Input, what happens as we plug in a 3? Let's try 3 in there. So 3, and then plug it into our little box. 3 times 3, right? You're substituting the 3 where the x is. So 3 times 3 gives us a 9. So let's plug it on our table. And the table is just a collection of coordinates that we come up with. Inputs and outputs, right? For that particular value that we plug in, we get an output. In this case, we plugged in a 3. Our output was 9. Let's try that again. What if we choose a 4? Okay, substituting a 4 for the x. 3 times 4. 3 times 4 gives us 12. Input of 4 give us an output of 12. So let's plug in our table. And once more, 5. Plug it in. 5 times or 3 times 5, depending on how you prefer to see it or do it. Okay. 3 times 5 gives us 15. And once again, a collection of tables. Now we can graph it on a piece of graph, or depending on how you choose to graph it, right? But for reference, we're just going to leave it at that point. Do keep in mind, you can make tables, inputs and outputs, right? That's the form here. So, quick sketch. Independent, single quadrant format. Which one's our independent variable again? Oh yeah, x. X is always our independent variable. It's the horizontal axis of our graphs. And in this case, we have a single quadrant for reference. So therefore, on our vertical axis, we have the output or the y values, right? In other words, dependent variable. So we have independent, always the x-axis. Dependent, always the y-axis. And in general, for other formats of graphing, meaning 4-quadrant graphs, similar concept applies still. The dependent variable is your y value. The independent variable is your x value still. Agreed? And If we do a quick sketch of a graph, not necessarily the values that we have above, but just for reference, it's a quick sketch. This is a decrease in line. Intercepts. Where do we see the intercepts? Well, the intercepts cross the y-axis and the x-axis, agreed? So it's just a matter of visualizing it. So let's see. Y-intercept, there. You may see a small blue dot there. Right there. Okay, that's our y-intercept because it crosses the y-axis. I don't need to know the value of it, agreed? But I know that it's the y-intercept because it crossed the y-axis. Likewise, we call it the y-intercept, and we automatically know something from now on. And this is something I like for you to memorize if possible. Memorize that your x value is always 0 if you're looking for the y-intercept. It doesn't matter what the y value is at the moment because I haven't given you one. But you should automatically know that it doesn't matter where it crosses the y-axis, your x value is always 0. So anywhere on the y-axis, x is 0. And now let's look for the x-intercept. There it is. X-intercept. Okay, x-intercept. Let's label it as the x-intercept. And it's similar to the y-intercept. There's something we can memorize that will help us out for probably the rest of our lives, right? And that is that on the x-intercept, y is always 0. So something to memorize. Y is always 0 for the x-intercept. Notice the opposites of reference. X-intercept, y is 0. Y-intercept, x is 0. So please, if you memorize this, it'll help you out for the rest of your life. And it'll make your life so much easier in many cases.